Okay, so good evening, all of you. The objective of today's session is to understand how this load cell will work. Particularly, we will talk about the strain gauge load cell, right? So let's start. Basically, these are the applications of load cell. That is the weighing machine or small weighing scale, or not it is restricted to small, but in the larger scale, obviously, to weighing bridge also this load cell can measure the total amount of force or weight or load. It is not restricted to that a weight measurement, but definitely with the help of hanging arrangement, we can actually measure the total amount of force which will acting on particular hanging mechanism. And finally, that torque meter. The torque meter is also equipped with this load cell, which will restrict the force or torque which we will applied to any machines. So that torque restriction can be possible by mean of this load cell. So these are the applications, few applications, which is actually uh, equipped with load cell. Basically, this load cell is simple sensors or transducer which will convert the total force or load applied into that electric signal. So that electrical signal might be in form of voltage change or either current change or either in frequency change. It is depending on the types of load cell. Now, basically, there are two different types of load cells are we can categorize. First one is resistive type of load cell, which is based on resistive principle, and second one is capacitive load cell, which is working based on capacitor principle. Today we are discussing about strain gauge, which is ultimately one kind of resistive type of load cell. So what mean by resistive load cell? So this is how this resistive piezoelectric sensors is look like. Basically, when you apply the load or force, that force or load is sensed by sensor, that is piezoelectric sensor, and due to that forces, the resistance will change. That is what principle is. Once the resistance will change, that resistance change will affect on the voltage output. So on the dial, we are having on the output side, we are having change of the voltage. So with the help of voltage change, we can recognize what is the change in resistance, and via resistance, we can calculate what is the amount of force is acting on that element. So this is what the basic principle. To sense this resistance, obviously they are using elastic member. This is the elastic member, or we can also refer as elastic foil. Now where it will attached or how it will positioning in that load cell is, see, it is look like this. Now this entire component is referred as a load cell, right? In that, at 4 different location right now, in this 4 different location, we are we are having this the load, the resistive sensor that is called as a strain gauge. Now this is called as a strain gauge. So we are actually attached 4 strain gauge at 4 different locations. Now that strain gauge can be attached by means of some adhesive material with this load cell. Now what happened when you apply some forces on this load cell? What happened? Due to that forces, this load cell will be comes under deformation. Now see, due to that deformation, this 4 different strain gauge experience different nature of either compression or either tensile stress. See, on the top side, when you apply the load, definitely this strain gauge will experience the compression stress. Due to compression stress, it will shrink. On the other hand, this left hand side strain gauge experience the tensile force or tensile stress. Due to that tensile stress, it will elongate it. See how this look like. You see on the very right hand side, This is figure A indicating the natural or neutral position. Without applying any load, this strain gauge is look like this. This is the circuit of that strain gauge. Through this circuit, we can have initial resistance value. So this circuit having certain initial resistance value, and due to that resistance, this terminal indicating certain voltage. If there is no resistance change, definitely this terminal indicating 0 voltage. Now, when the strain gauge comes under tensile stress, this B diagram B indicating the tensile stress condition. So this one is actually experienced the tensile stress condition. During the tensile stress, due to the tensile load, this resistive circuit will elongated, and total elongation in terms of length, obviously. So once the length will increasing, definitely that resistance will increasing. This is simple straightforward equation. Resistance is equal to rho L by A. So due to elongation, the resistance, due to elongation, the length will increase, and because of that, the resistance in this tensile strain gauge is continuously increasing. What happened with the other one? So this other strain gauge is actually experience the contraction. Due to contraction, the length will decrease. So that decrement in the length will reduce the total amount of total resistance in that strain gauge. So this is basic principle. We are having 4 different strain gauge. In that 4 different strain gauge, the resistance of that strain gauge is altered. Somewhere in the 2 strain gauge, due to tensile, it will increasing. In the 2 other one, how due to contraction, it will decreasing. So this is what actually the basic principle. Now, how we can accommodate that for a resistance, and how can we reflect it in terms of voltage change? So only option that is called as a Wheatstone Bridge circuit. In that Wheatstone Bridge circuit, we can accommodate the resistance in parallel. See, this is what actually Wheatstone Bridge circuit you already landed at your diploma or somewhere in electrical subjects. So what actually Wheatstone Bridge circuit, when this circuit will completed, obviously it will reflected in terms of voltage over here. Now what happened when this the value of this resistance, individual resistance value R1, R2, R3 and R4 will change. It will reflected in the voltage value. So this is the change of resistance is our input, and the change in the voltage is our output. So that equation is also available. Mathematically, we can find out that change in voltage when the resistance will change with the help of these equations. But our intention is to understand how it will work. So see here, this is small diagram. See, this is Wheatstone Bridge where we are having, let's say, R1, R2, R3 and R4. Let's say initially when the circuit is not completed, definitely there is no current will pass, and because of that the 0 voltage is indicating. Initially we are having this 4 resistance with a magnitude of 350 ohms, let's say. Now, so when we applied certain amount of load, definitely because of that load, this reflection or this action is actually supplied to this 4 different strain gauge. That here it will experience the tensile force, it is compression force, tensile force and compression force, and due to that the resistance will change. See, the resistance due to tensile, the resistance will change from 350 to 350.7, let's say, and in this side the resistance will decreasing. Now according to this value, definitely the voltage will change according to that equations, right? Equations we look into last slide. So based on that voltage change, we can actually have idea what amount of force is applied. Now see, there are reverse correlation we have to think about. Now see, before look into the various types of load cell, let's see. See, this voltage is reflected due to change in resistance. Now why this resistance will change? This resistance change is directly proportional to change of length. This change in resistance is directly proportional to change in individual length. Now this length ultimately, why this length will change, resistance length, the element of resistance length will change because it will experience the strain. Strain is what actually change in length divided by original length. So from that, because that how that length will change, it is due to strain. Strain is experienced by that load cell. Now that once you know the change in length, definitely on the reverse side you can able to calculate the strain. Now once you calculate the strain, definitely we have Poisson equations through which you can relate the stress and strain. So once you have idea about the strain value, you can able to get the stress value. Once you have find out the stress value, so stress is ultimately force by area. So ultimately we are reach what amount of force is ultimately act on this element. So this is how reverse calculation done by mean of certain sensors. Definitely that we will not do that calculation, but this entire load cell is made such that it will make a reverse calculation and reach from this output, like let's say from 2 megawatt millivolt of output, they reach to what amount of force or what amount of load is acting on this strain gauge. So this is what principle or concept behind this strain gauge. Particularly this type of strain gauge is used like generally what I show, that is the S type of strain gauge. In this S type of strain gauge, see this is the four side. This is the Wheatstone Bridge circuit. In this they are actually having a Wheatstone Bridge circuit. This 1, 2, 3, and 4 sensors will experience the tensile and compressive load. In the button type load cell, obviously 2 on the top and 2 on the bottom side, that strain gauge is attached. In canister also 2 on the top and 2 on the bottom. So like it is a different type of arrangement. Ultimately the basic working principle is almost similar. All are working based on Wheatstone Bridge circuit, ultimately indicating the voltage change in the output, and through that voltage change there are a correlation fitted in that, and based on that they will indicating the total amount of load acting on that cell. uh, so these are various types. This is beam type or column type, shear type or other type of this. These all are general load cell types. uh, and I mentioned that the load cell actually functioning based on the what amount of voltage. See, this is the voltage change. Ultimately that voltage change is in terms of millivolt. Obviously there is minor change in length, so that it will reflecting in minor change of voltage, but it is amplified in terms of through the amplifier, and through amplification definitely we are getting the reading. But during that process there are certain issue. See, this load cell is using widely from like so many years now, but see, it will provide accurate reading, but it required many tedious steps or process during the manufacturing time. See, who are the manufacturer? They have to taken care about that all small things, like the correlation between the voltage and resistance and the change in length and the strain and the stress, and finally we reach to that forces. So these are the conversion pattern. So every time they have to taken care about the consideration of minor changes of all parameters. Now sometimes this type of error is observed actually during this in this load cell. One is called as a hysteresis error. What actually hysteresis error? It is a generally differences between two load cell output readings when you are applying similar loads. See, if we are having two different types of, let's say S type of and button type of load cell, even though if you are applying similar amount of load, then also if it is indicating the different reading of load, then definitely that error is referred as a hysteresis error. Creeping error, that is ultimately, see, what is the nature of this load cell, how we will use. Generally we apply load and then then this when you apply the load, obviously the change in resistance and voltage will indicating the total amount of applied load. So suddenly you apply load and remove it. So when you remove it, obviously that resistance panel will comes into their original positions. But if it is not case, then what happen actually, if you are continuously applying constant load for longer period of time, so in that case this resistive panel continuously, either it is in the form of expansion or either it is in form of contraction. For if it is happen for longer period of time, then this load cell actually indicating the error after a certain period of time, which is called as a creeping error. There are also error due to temperature. Definitely resistance is directly depending on temperature also. If the temperature is higher, then definitely the calibration of the calibration between the resistance and voltage will affected. So that is also you have to consider when you are actually working with higher temperature or very cold temperature at that time. This load cell will actually give the error due to temperature. So this all error actually need to calibrate it. That is done by mean of manufacturer only. That manufacturer can calibrate that error working. And if any queries and doubts regarding this load cell, then you can actually ask in this session. Now it is open for all.